Okay, so this is going to be the next type of method. So in the previous video, we saw that we can do substitution method. So now we're going to do elimination method. Okay, so this is going to be elimination. So another way in which we can solve these types of problems. So we had graphing, substitution, now it's elimination. So elimination is very straightforward. The whole point about elimination is that you want to eliminate variables, common variables with opposite signs. Okay, so let me give you an example. So let's say we have this system of equations. You have x minus y is equal to 3, and then x plus y is equal to 5. Okay, so if you see, we want to eliminate common variables. So we have x's, these two x's have exactly the same x, exactly the same number in front of it, which is a 1, but they have to have opposite signs. So in this case, this one doesn't have opposite signs, but the y's do. So you can eliminate them. So the whole point of it is that you just want to add straight ahead. So x plus x is going to give me 2x. Negative y plus y is going to give me 0. Equals 3 plus 5 gives me 8. And all we got to do is just solve. Divide by 2, divide by 2. X is equal to 4. All right, that's one of them. Now we got to solve for y. So we can plug them into whatever equation we want. We either can do it in equation number 1 or equation number 2. This time I'm going to do equation number 2. So x plus y is equal to 5. I'm going to plug in this 4 in there. 4 plus y is equal to 5. Move the 4 over. So y is equal to 1. All right, so how do we write our answer? This is going to be 4, 1. Remember, the x always goes first, followed by the y. Okay, that's the elimination method. It's actually very straightforward, easier than the substitution method. Okay, so let's try another problem. So something that's not as straightforward. Okay, so here's another example. So let's say we have negative x plus 5y is equal to 8, and then 3x plus 7y is equal to negative 2. Okay, so we want to solve for x and y. So we want to solve this system. That's maybe what the direction should be, solve. All right, so one of the things that you want to do first is try to eliminate any common variables. So the y's don't seem that they have anything in common because they're both y's, but you have a 5 and you have a 7, so those are not quite in common. So maybe don't deal with the y's. The x's here, well, this one has a 3, this one doesn't have a 3, but they have opposite signs. But this one, what do I wish this one had? Well, I wish this one had a 3. So why don't I multiply this entire problem by a 3? Okay, so that will hopefully give me what I want. So I'm going to distribute this 3 to all 3 terms. So I'm going to have negative 3x, 5 times 3 is going to give me positive 15y is equal to 8 times 3, which is 24. Okay, and this one I'm not doing anything to it. So it's going to be 3x plus 7y is equal to negative 2. All right, so this negative 3x and this positive 3x are going to cancel out. And then 15 plus 7 is just going to give me 22y is equal to 22. Divide by 22 to both sides. So y is going to be equal to 1. Okay, all right, so that's my answer. So notice that when I multiplied by the 3, it made everything scale up by a factor of 3, but I was able to cancel out this other 3x. Okay, now that I have that y, I can solve for my x value. Now, which one would be easier, to plug in equation number 1 or equation number 2? Well, I think equation number 1 might be easier here. So negative x plus 5y is equal to 8. So negative x plus 5, y in this case is equal to 1, so I'm going to plug in the 1 in there. All right, so you're going to get negative x plus 5 is equal to 8. I'm going to move the 5 over, so I'm going to have negative x is equal to 3, and then I just finally divide by the negative 1. So x in this case is equal to negative 3. So my solution is going to be negative 3, 1. Okay, and that is my answer. Okay, how do I know if the answer is correct? I just plug them in and I should get exactly the same thing. All right, so now let's do the third case. Now a third case is a little bit more involved. So elimination method is still one of my favorites, but still sometimes you have to work a little bit harder, especially when you have these types of problems. 4x minus 7y is equal to 2. And then 3x minus 3y is equal to 6. All right, so now what we want to do, we want to solve for either x or y. Now notice here, can be a little bit tedious because this is a 4 and this is a 3. Well, they're not the same numbers. It's kind of hard to multiply by a number to get to the other one. Can't multiply anything to the 4 to get a 3, at least not with a clean number. Same thing with the 7 and the 3. On the y's. So what can I do? Well, in this case, I got to think about, what is a number that they both are divisible by? So if I look at the 4 and the 3, what is a number that they both can divide into? Well, the number that they can both divide into is 12. So what I'm going to do, I'm going to multiply this whole thing to try to get a 12 from here. So how do I get this 4 to be a 12? Well, if I multiply it by 3, I get a 12. How do I get this 3 to be a 12? Well, if I multiply it by 4, I can get a 12. Now, remember, in order for me to eliminate it, one of them has to be the opposite sign. So I can choose whichever I want. I'm going to choose the first one. Okay? Doesn't really matter. Now, notice I could have used the y also. The 7 and the 3. I can multiply, the lowest number that they both can divide by is 21. I could have done that too, and it will still give me the same answer. So in this case, we had to multiply both problems by the same number. Okay, so what is that going to give me? Well, this is going to give me negative 12x, because remember there's a negative there. A negative and a negative is going to give me a positive 21y. It's equal to a negative 6. Okay, now when I multiply this one by a 4, it's going to be positive 12x minus 12y is equal to 24. Okay, so what happens? The x's are going to go away. All right, and then I'm going to take this this 21 and I'm going to subtract it by 12. And then what I'm going to get is I'm going to get 8. Okay, I mean 9. Y is equal to, and then 24 minus 6 is going to give me 18. Okay, and I need to make sure that all my signs are good. Okay, then I'm going to divide by this 9. I'm going to get y is equal to 2. Okay, and that is my answer for that one. Okay, now that I know that y equals 2, I can plug it into the other one. Now I can plug it into these equations if I wanted to, but I rather use the other one. So I'm going to use the second one, this 3x minus 3y equals 6, which is equation number 2. So I'm going to plug in that 2 into the y. So I get 3x minus 3 times 2 equals 6. I get 3x minus 6 equals 6. I add the 6 to both sides. Okay, so I'm going to get 3x is equal to 12. And then when I divide by this 3, I'm going to get x equals 4. Okay, so my answer is going to be 4, 2. All right, and that is my answer for that one. Okay, so now before I finish up the video, I just want to go ahead and give 2 different types of problems. Okay, or I should say 2 special cases. Okay, so far we've been getting solutions for every single problem. So that means that I have 2 lines that intersect at one point to provide one solution. Okay, now sometimes you might get a problem where you don't get a solution at all, where actually these 2 lines never touch each other, and this is what we call the lines parallel. Here, there is no solution. So whenever you have parallel lines or things that are never going to touch, you get no solution. You might actually have a line that is on top of another line. Okay? In this case, if you have a line on top of another line, you get infinitely many solutions. Infinitely many solutions. Okay? So we already know when we get one solution. Okay, it's really easy. You just get an answer. Now, when do you get no solution? So let me give you an example, a very quick example of what that might look like. So let's say I have this problem, x plus y equals 3, and then x plus y equals 7. Okay, so let's solve this type of problem. So one of the things that I can do is I can get rid of this x if one of them was opposite. So what I'm going to do is I'm going to take the opposite of the other one. So I'm going to multiply everything by a -1, because then that would make that a negative, and then I can cancel it out. So this is going to give me -x minus y equals -3. This one, nothing happens to it. X plus y equals 7. So notice my x's are going to cancel out, but also my y's cancel out. So I'm left with a 0. Then -3 plus 7 is just going to give me a +4. Notice the 0 equal 4? Nope. So whenever you see a contradiction like this is a contradiction. This means no solution. You don't need to do anything else. This is just going to be a no solution answer. Okay, because nothing happens. So this actually are parallel lines. Okay. Now, how do I know if I have infinitely many solutions? Well, this is the case that you get it. So let's say you have x plus y equals, let's make this into a 2x plus y equals 4. And let's make this into a 4x plus 2y equals 8. So let's say you get something like that. All right, so how am I going to do this problem? Well, let's use the elimination method. You can also use substitution method if you like. So I'm going to multiply this whole top part by a -2 because I need to transform this into a 4. When I multiply it by 2, it becomes a 4. Multiplying it by a negative will cancel it out. So I'm going to get -4x minus 2y equals -8. And then this one is just going to be right below it. 4x plus 2y equals 8. Okay, so now this goes away, and this goes away too. So I get 0 equals 0. So whenever you get something that looks like that, this is actually what we call an identity. So whenever you have an identity of something equals something, this means infinitely many solutions. Okay, and that's what you will write. Okay, later on, when we do 3 by 3, 3 variables and 3 equations, we will learn how to write infinitely many solutions. But for right now, this would be sufficient. Okay, so that's it for this particular section. In the next section, we're going to go over the word problems.